This is a continuation of the Cal 1 Test 2 review. So we're looking at this problem here. It says find the derivative of y with respect to x. So when I look at this problem, alright, I see trig functions. Now this is just a number, just a coefficient, and this is just sine x and just cosine x. So it's going to work like those regular old trig function derivatives. Alright, just sine x. So, and then it's also a sum. So I'm going to take each term individually. So I'm looking at just 9 sine x. And I'm going to take its derivative. So we would say y prime equals, the derivative of that would be 9 cosine x. And then we take the next term, which is a plus. Alright, and then the derivative of cosine would be negative, we'll just do it like this, 2 negative sine x. And then we can rewrite this as 9 cosine x minus 2 sine x. So when it is just cosine x, sine x, tangent x, when it's just that, nothing else, no squares, no products, just an x, then I just take each individual term and take its derivative the regular way. Alright, this says find the derivative of y with respect to x using the rules for finding derivatives. So when I look at this problem, alright, we have y equals pi x to the 7th minus 2 x to the 9th minus 9x to the negative 3. Okay, so pi is just a number, remember 3.14 and a lot of decimals after, so you just treat it as a number. And so the derivative of this would be y prime, and then we just say 7 times pi, and you can just leave it 7 pi is fine, don't try to make it a decimal. X to the, take one away from the 7, minus 2 times 9 is 18, x to the 8th. And then we have negative 9 times negative 3 is positive 27. And remember, we're taking 1 away, so negative 3 minus 1 would make negative 4. And so your computer may accept the answer as this, but traditionally we don't like to have those negative exponents. So I would rewrite it as this, taking the x to the negative 4 and dropping it to the bottom. Okay, so the computer says this answer is okay, but maybe if you try this and it counts it wrong, then of course send me an email and ask me to look at that problem. Okay, and we'll go from there. All right, let's look at the next. All right, the next problem says find the derivative using the derivative rules. Alright, so when I look at this problem, it says y equals x times x to the 6th plus 3. Let me get some paper here where you can see what I'm writing. Alright, so we'll have y prime equals, and then this is a product. Now, there are two ways you can work it out. Right? You could say first times the derivative of the second plus second times the derivative of the first. But this one, since you can distribute that x in there, it might be easier to say x times x to the 6th is x to the 7th, and x times 3 is 3x. So to me that's easier, but if you still want to use the product rule, that's totally fine. If you do that, you should get the same answer. So now I just take the derivative of this. That would be 7x to the 6th plus 3. So if you do have a product and you can multiply it together, I mean, sometimes it's easier to go ahead and multiply it together if you can, and then you just have a sum or difference, and you can use the power rule on each individual term. So if you were going to work it out using the power rule, all right, then we would say first times the derivative of the second, which would be 6x, plus the second times the derivative of the first, which would be 1. Then when we multiply that together, we get 6. That's not right. What happened here? Oh, I know what I did. Sorry, I left off. I left that off. So that would be 6x to the 5th, which gives us 6x. I did something wrong. Okay, I see what I did wrong here. First times the derivative of the second plus the second. There we go. Second times the derivative of the first. I just chopped that second one off for some reason. Alright, so first times the derivative of the second would be 6x to the 5th. So when I multiply those together, that'll be 6x to the 6th. Then that'll be x to the 6th plus 3. Then I can combine those together. Alright, to get the exact same answer. Alright, so whichever way you want to do it, you can multiply it out and then use the sum and difference and power rule, or you can use the product rule. Your choice. Alright, the next problem is with the limit definition. I believe we worked one like that earlier. Alright, so with the limit definition, this is it right here. It's being nice and giving it to you there. Alright, so what this is saying is, alright, so h or delta x, it doesn't matter which one you use. You're going to take this and replace it, put it in x's place everywhere in your function. So we would say the limit as h approaches 0. And so I'm going to take x plus h and plug it in everywhere there is an x into my function. So that'll be 3 plus x plus h. So instead of that x, I'm going to put x plus h squared. And that's the only x in there. So then minus the function itself, be 3 plus x squared. And make sure you're subtracting the entire function and not just that first term. So make sure you put it in parentheses when you subtract it, or that you change the sign of everything that's in the function. All over h. Alright, make sure you carry the limit notation until you do your final substitution. Alright, so this will give us 3 plus x squared plus 2xh plus h squared minus 3 minus x squared all over h. Now at this time, something should be canceling out. So here the 3's are going to cancel, 3 minus 3, x squared and negative x squared, and then we're left with 2xh plus h squared. Alright, then there's a common h in the top. This h down here is what's causing us trouble when we substitute in the 0. So we need to get rid of it. So we're going to factor it out from the top. Now this h we factored out, and this h on the bottom will divide out. And we'll be left with the limit as h approaches 0 of 2x plus h. Now, when I substitute in the 0 in h's place, I will get 2x as my limit, as my derivative, as my slope. Alright, they don't give us a specific point, so this right here is the slope, or the derivative. Alright, once you do that, you can always go back and check your answer by looking at the original function and just taking its derivative. So if you look at this, the derivative of 3 plus x squared is simply 2x. And that is what our answer shows also. So that's a good way to check your answer, or do that first, and so that way you know when you get to the end if you have the correct answer or not. Alright, this problem. y equals x cubed times sine x. All right, this is a product, x cubed times sine x. So if I want to find its derivative, I want to use the product rule here. I can't distribute anything out to where I can do a sum and difference or use the power rule. So I have to do the product rule. So we're going to say the first times the derivative of the second plus the second times the derivative of the first. All right, now these are simply sine x, so I can use those basic trig derivatives. Derivative of sine x is cosine x. Then, if you want to rewrite it, you can. So that it says 3x sine x, to where that number is in front of the sine x. That's just a traditional way to write it. And that's the end of that one. All right, let's see what the next problem says. I keep leaving off my exponents, don't I? 3x squared. Sorry about that. So let me start that one over. All right, the problem says x cubed. Make sure I get this clear here. All right, here's our problem. It's a product. So we're going to say first times the derivative of the second plus the second times the derivative of the first, and that's 3x squared. All right, so make sure that x squared is on there. I left my 2 off there. All right, and so then from there out, that is good. That's the answer. Okay, let's try the next one. See if I can get my derivatives correct here and not leave off exponents. All right, the next one says y equals x squared, x to the 9th plus 2x. All right, so when I look at the problem, this is a sum. So I'm going to take each individual term and apply the rules as necessary. So x to the 9th, I'm going to multiply by 9, subtract 1 from the exponent. Then looking at the next term, multiply by 1, subtract 1 from the exponent. And then that's the answer, final answer. All right, looking at the next problem. All right, this is a quotient. I'm dividing, so I want to use the quotient rule, which remember is low d high minus high d low over the low squared. All right, so for this one we'll say low, which is x minus 7, or the bottom times the derivative of the top. So low d high, so the derivative of 4x minus 7 is simply 4 minus high times the derivative of the low, so that'll be 1, all over the low squared. Then at this point you should be able in some way to simplify the top. Don't worry about multiplying the bottom out, just leave it in its squared form. So that would give us 4x minus 28. And then don't let this minus sign get you. Whatever you get here, you're going to be subtracting it. So 4x times 1 is negative 4x. And negative 7 times 1 is negative 7, but we're subtracting it, so it becomes plus 7. So minus negative 7 becomes plus 7. All right, then we have negative 28 and positive 7 make negative 21 over x minus 7 squared. Okay, let's look at the next one. All right, so the next one says y equals cosine of 8x squared minus 3x. So notice this is not cosine x. There is more involved. So this is where you're going to need to use the chain rule, because it is not just cosine x. All right, we need to use the chain rule. So what you're going to do is take the derivative of the mama, All right, and this is mom.